Welcome to the AWS Certified Solutions Architect Associate Question Bank series. In this video, we'll work through 10 exam-style practice questions designed to help you prepare for the AWS certification exam. For each question, I'll reveal the correct answer and walk you through a detailed explanation, not only why the correct answer is right, but also why the other options are wrong. Here's how to get the most out of this video. When each question appears on the screen, pause the video, choose your answer, and then press play to see how you did. And if you'd like to review the previous 10 questions in this series, just click the previous video link at the end of this video. Ready to test your AWS knowledge? Let's get started. Question 31. A company needs a disaster recovery strategy that keeps a minimal version of its environment always running and can scale up quickly during a failover, balancing low recovery time with cost. Which strategy does this describe? The correct answer is C, Pilot Light. The Pilot Light strategy keeps core components running at minimal scale and rapidly scales up on failover, balancing recovery time and cost. Now, why the other options are wrong? Backup and restore is incorrect. Backup and restore has the lowest cost but the slowest recovery, not a minimal always-on environment. Multi-site active-active is incorrect. Multi-site active-active gives the fastest recovery but at the highest cost. Single availability zone deployment is incorrect. A single AZ deployment provides no cross-site disaster recovery. Question 32. Multiple EC2 instances across different availability zones need concurrent access to the same shared file system. Which service provides this? The correct answer is D, Amazon EFS. Amazon EFS is a shared elastic file system that many instances across availability zones can mount concurrently. Now, why the other options are wrong? Amazon EBS attached to one instance is incorrect. A standard EBS volume attaches to a single instance in one AZ, not shared across AZs. Amazon S3 Glacier is incorrect. S3 Glacier is archival object storage, not a mounted shared file system. An EC2 instance store is incorrect. An instance store is ephemeral local storage tied to one instance. Question 33. A company wants unhealthy EC2 instances in an autoscaling group to be automatically replaced. How is this best achieved? The correct answer is A. Use ELB health checks with the autoscaling group, so failing instances are terminated and replaced. When the autoscaling group uses ELB health checks, instances that fail are terminated and automatically replaced to maintain capacity. Now, why the other options are wrong? Manually monitor instances and replace them by hand is incorrect. Manual replacement does not provide automatic resilience. Disable health checks to avoid unnecessary restarts is incorrect. Disabling health checks prevents automatic detection and replacement of failures. Increase the instance size to prevent failures is incorrect. A larger instance does not guarantee against failures or provide automatic replacement. Question 34. Instances in private subnets across two availability zones need reliable outbound internet access for software updates. How should NAT be designed for high availability? The correct answer is B. Deploy a NAT gateway in each availability zone and route each subnet to its local NAT gateway. Deploying a NAT gateway per availability zone removes a single point of failure and keeps outbound access available if one AZ fails. Now, why the other options are wrong? Use a single NAT gateway in one availability zone for all subnets is incorrect. A single NAT gateway is a single point of failure. If its AZ fails, other subnets lose outbound access. Place the instances in public subnets with public IPs is incorrect. Putting instances in public subnets exposes them to the internet and changes the architecture's security posture. Remove the route to the internet entirely is incorrect. Removing the internet route would block the required updates. Question 35. A media company receives video files that must be transcoded by a fleet of worker instances. The work should continue even if some workers fail, and jobs must not be lost. Which design is most resilient? The correct answer is C. Put transcoding jobs in an Amazon SQS queue that worker instances pull. An SQS queue decouples job submission from processing, so workers can fail and recover without losing jobs. Now, why the other options are wrong? Have the upload server call each worker directly over HTTP is incorrect. Calling workers directly tightly couples the system and loses jobs if a worker is down. Store jobs in a single instance's memory is incorrect. Storing jobs in memory loses them if the instance fails. Process all jobs on one large instance is incorrect. A single large instance is a single point of failure with no resilience. Question 36. A company wants automated, scheduled creation and retention management of Amazon EBS volume snapshots. Which service automates this? The correct answer is D. Amazon Data Lifecycle Manager. Amazon Data Lifecycle Manager automates the creation, retention, and deletion of EBS snapshots on a schedule. Now, why the other options are wrong? AWS CloudTrail is incorrect. CloudTrail logs API activity and does not manage snapshots. Amazon CloudFront is incorrect. CloudFront is a CDN and does not manage EBS snapshots. AWS Global Accelerator is incorrect. Global Accelerator improves network performance and does not manage snapshots. Question 37. A company wants to reduce latency for globally distributed users downloading static images and videos from Amazon S3. Which service should it use? The correct answer is A. Amazon CloudFront. Amazon CloudFront is a content delivery network that caches content at edge locations close to users, reducing latency. Now, why the other options are wrong? Amazon SQS is incorrect. SQS is a message queue and does not deliver content to users. AWS Secrets Manager is incorrect. Secrets Manager stores secrets and is unrelated to content delivery. Amazon RDS Multi-AZ is incorrect. RDS Multi-AZ improves database availability, not global content latency. Question 38. A read-heavy application repeatedly runs the same expensive database queries. Which service can cache results in memory to reduce database load and latency? The correct answer is B. Amazon Elasticache. Amazon Elasticache, Redis or Memcached, caches frequently accessed data in memory, reducing database load and latency. Now, why the other options are wrong? Amazon S3 Glacier is incorrect. S3 Glacier is archival storage, not an in-memory cache. AWS Config is incorrect. AWS Config tracks resource configuration, not caching. Amazon Kinesis Data Firehose is incorrect. Kinesis Data Firehose delivers streaming data. It is not a query cache. Question 39. An application using Amazon DynamoDB needs microsecond read latency for a read-intensive workload. Which solution provides this? The correct answer is C. Amazon DynamoDB Accelerator, DAX. DynamoDB Accelerator, DAX, is an in-memory cache for DynamoDB that delivers microsecond read latency. Now, why the other options are wrong? Amazon RDS read replicas is incorrect. RDS read replicas apply to relational databases, not DynamoDB. Amazon Redshift is incorrect. Redshift is a data warehouse, not a DynamoDB cache. Amazon S3 transfer acceleration is incorrect. S3 transfer acceleration speeds S3 uploads, and is unrelated to DynamoDB latency. Question 39. An application using Amazon DynamoDB needs microsecond read latency for a read-intensive workload. Which solution provides this? The correct answer is C. Amazon DynamoDB Accelerator, DAX. DynamoDB Accelerator, DAX, is an in-memory cache for DynamoDB that delivers microsecond read latency. Now, why the other options are wrong? Amazon RDS read replicas is incorrect. RDS read replicas apply to relational databases, not DynamoDB. Amazon Redshift is incorrect. Redshift is a data warehouse, not a DynamoDB cache. Amazon S3 transfer acceleration is incorrect. S3 transfer acceleration speeds S3 uploads and is unrelated to DynamoDB latency. Question 40. A transactional database on Amazon EC2 requires high, consistent IOPS and low latency from its block storage. Which EBS volume type is most appropriate? The correct answer is D, provisioned IOP SSSD, IO1/IO2. Provisioned IOP SSSD, IO1/IO2 volumes deliver high, consistent IOPS and low latency for IO-intensive databases. Now, why the other options are wrong? Cold HDD SC1 is incorrect. Cold HDD SC1 is for infrequently accessed data and offers low performance. Throughput-optimized HDD ST1 is incorrect. Throughput-optimized HDD ST1 is for large sequential workloads, not high IOPS transactional databases. Magnetic standard is incorrect. Magnetic standard is a previous generation low-performance volume type. And that's a wrap on this video. Nice work getting through those 10 questions. If this helped, you're going to want the complete set, all 390 exam-style questions, with full explanations across every exam domain are available in our Udemy course. The link is in the description below. Make sure you subscribe so you don't miss the next video, where I'll walk you through 10 more. See you in the next video.